At this step, we will consider the way how to create the curtain wall panels families and how to create geometry arrays within the family editor. But before that, we must understand how the curtain walls are arranged themselves. To do this, let's create a project and select Metric Architectural Template. From the Revit point of view, the curtain wall is a walls system family and is created with the corresponding tool on the ribbon. Next, open the drop-down list of families in the Properties panel and find the curtain wall family. In the architectural template, it has three types: curtain wall, exterior glazing, storefront. They differ in a predetermined grid of the panels and mullions, which were established through the type parameters. I will choose the exterior glazing type. Let the height of the curtain wall be arbitrary. We can change it through the Properties panel. The curtain wall is formed along the line. Let's go to the 3D view. We got such kind of object. It can be entirely selected, but in fact, it is composite. There are several nested families in the curtain wall, which is itself a system family. We cannot change the principles of its construction. We can only change the values of the parameters, but custom families can be nested in the curtain wall. These are curtain wall panels and mullions. Mullions are not assigned for this type, and they are of little interest to us now. We need to consider how the curtain wall panels work. The configuration of each panel depends on the grid of the curtain wall. Grid can be set via curtain type properties, but we can also select grid lines and move them. The parts of the curtain wall are pinned by default. That is, when I select the grid line, such pin icon appears. It signals that the object is pinned. The pinned object cannot be replaced. Therefore, first, this line must be unpinned by clicking on this button or the Unpin command on the ribbon. Now we can freely change the dimension snapping the grid line. The same applies to horizontal grid lines. They can also be unlocked and moved. As for the panels, they are selected through the Tab key. You can move the mouse cursor over the grid line and press Tab key several times. The panel will light up sooner or later. First one, then the other one. Then it can be selected. Curtain wall panels can also be pinned. It depends on type properties of the curtain wall, but it doesn't apply to us in this case. Through the Properties panel, we can change the type of the curtain panel or select a different family. There are several curtain wall panel families in Revit. Glazed, solid are types of the system panel, and they are basically different in materials. Empty. This is the type of the empty system panel. This one creates a void in the curtain wall, i.e. a hole. System panels are unique in a way that they may not have a rectangular outline. That is, such panels can be trimmed with curtain grid lines at an angle. But one way or another, any panel fits into the dimensions between the grid lines. That is, when we change the grid, the panel automatically expands or contracts, adjusting to the configuration of the curtain wall. Also, Revit gives an opportunity to create your own custom curtain panels that we can insert instead of the system ones. I'll close the floor plan and create a curtain panel family. Select the Metric Curtain Wall Panel template and open it. We are on the floor plan ref level. And here we see the boundaries that are predefined by the reference planes. This is the dimension of the panel in width. We can designate this dimension by a parameter right away. To do this, set a size and associate it with the parameter. This must be the instance parameter and the reporting parameter, since the dimensions of the panel will adjust to the grid of the curtain wall. We will not be able to control the width of the panel directly through this parameter. We will control the grid, and the width will change itself. The report parameter is required in cases when we need to read data from a situation and not to manage it. Click OK. Let's move on to the exterior elevation view. Here we see another additional reference plane, which determines the height of the panel. The same reference plane is at the bottom, in the same position as ref level. The reference level line in this template was deliberately made shorter, so that when creating geometry, it was not possible to accidentally snap to it instead of the reference plane. The panel geometry must be bound to the overall reference planes. Otherwise, it will not be able to adapt to the grid of the curtain wall. Let's put a parameter here that will be responsible for the height. This will also be a reporting parameter. Now let's create some basic geometry, for example, an extrusion element. Close the locks and draw a hole in the center of this extrusion. I will not snap precisely to the center, so I will build an arbitrary hole. For example, this one. So far, I will not parameterize it. Our family is ready. Let's upload it into the project. Curtain panel families are the ones that can only be inserted into a curtain wall. Therefore, the program doesn't automatically offer us to place the instances of the family after loading it into the project. Let's select one of the existing panels. And let's pay attention to the Properties panel. We can replace one family with another through it. This is our curtain panel family. And here a hole appeared. Since we didn't set the position of the hole, it will move spontaneously. In this case, I just wanted to show you how to replace one panel with another. Now, let's create a real panel which can be used in your projects. This new panel will look like louvers, and to form it, we need a separate slot of these louvers. We will make it a nested family. Select the metric generic model template and click the Open button. Let's build a couple of reference planes here that will define the length of the slot. Let's connect them to the center and set the length parameter. That we will make an instance one. Next, let's move on to the elevation view. Here we form a reference plane that will set the height of the slat. I will set the dimension from one reference plane to another. The dimension snaps to the level by default. I will select the reference plane through the Tab key. Let's say the height of the slat will be constant. I will make it equal to 200 mm. I will close this size with a lock. We form the slat by extrusion on the left elevation view. Let's draw an oblique line here. for example, at an angle of 120 degrees. And I'll copy this line. Next, we will create the borders of the sketch at the top and bottom. I will merge the ends of the outline and anchor the sketch lines to the reference planes. If the height dimension of the slot was not constant, it would also be necessary to anchor the sketch lines by angular dimensions and log them, but we will not do this now. I'll finish building the extrusion. Close the elevation view. We can also close the second elevation. Lengthen the resulting extrusion element in the floor plan and snapping it to the reference planes. Make sure you close the locks. We will also create a material parameter. We can say that our family is ready. Let's save it. And load this family into the curtain panel family. Open the floor plan and place one instance of the nested family. Here we have another extrusion geometry that we created earlier. I will delete it. The slat instance must be aligned with its center reference plane. We will also align with the second reference plane to position the slat in the Y direction. Now let's pass parameters to the parent family. We will link the slot length to the width parameter. We see that the dimensions are set correctly, and the width is a reporting parameter that will be read situation in the project from the curtain wall configuration, and then transmit value to the slat length. I made the material into the type parameters so that we will pass it through the type properties window. Let the analogous parameter also be the type 1 in the parent family. Let's move on to the exterior elevation view. We need to spread the slats in height. To set the distance between two adjacent slats, create an additional reference plane and bind it through the parameter. I will call this parameter step, and it will be an instance one. Now, select the already placed slat and use the array command. If we want to manage the array in the future, we must have the Group and Associate checkbox. It is activated by default. Next, let's set the number of elements in the array to 5 and set the method of its construction, move to second. We can also specify the move to last method. In this case, we will indicate the distance from the lower reference plane to the upper one, and 5 elements with equal spacing will be placed between these planes. But still, I will choose the first method. I copy the first element. We can immediately change the number of elements in the array, but I won't do that yet. The second element must be attached to the reference plane to which we copied it. Let's do it through alignment. And don't forget close the locks. Next, select the one of the array elements. A special symbol through which the array can be manipulated appears. If we select this symbol, then we'll see a label that can be associated with the parameter. Let's add such parameter. Its data type is integer. He is responsible for the number of elements in the array. Let's call it number of slots. And that will be an instance parameter. Now, let's make the slots automatically fill the panel height. Let's go to the Family Types window. Step, height, and number of slots are the instance parameters. We can link them together using a formula. Suppose one of these parameters was a type 1 and the other was instance 1. In that case, we couldn't define this type parameter through the instance 1 in the formula. Revit would give an error, but now we will not have such problems. The number of slots will be equal to height divided by step. I will copy the height name. Then the division sign, and write the name of the parameter step. Make sure you pay attention to the case. That is, if I wrote step with a lowercase letter, Revit would not recognize the parameter we created in this family. We see that the number of slots has been recalculated. If we change the step, then the number will also change. This is how arrays work. Let's save our family. I'll call it louvers and load it into the project. Now let's change one of the curtain wall panels. If in your version of Revit, our family doesn't appear in the list of families suitable for curtain panel replacement, it may be present here. If we select it, we will see that the family is installed. The number of slots was matched automatically. If we select our family for a smaller panel, then all the things will also be recalculated correctly. We can move the grid lines at any time, and the family will adjust. We can also change the parameters of the array by changing the step. Note that within the Magic Curtain Wall Panel template, you can select different categories to create families, in particular, curtain panels, doors, and windows, which means that depending on the selected category, our panel will get into one or another schedule in a project. It's also worth keeping in mind that each curtain panel will be presented in the schedule as a separate object. In contrast, the entire curtain wall will not be included in the schedule.